Okay, so this is the last example in section 2.1. A parking area is to be constructed adjacent to a road. The developer has purchased 340 feet of fencing, determined dimensions for the parking lot that would maximize the area. All right, so we have this rectangle. It has two short sides, which are X, and a long side, which is Y. We know that the perimeter of that three sides of that rectangle will be 340 feet of fencing. And we know that we want to figure out the dimensions that are going to maximize the area of this parking lot. And the only thing we've learned how to maximize in this section is a quadratic function. We don't really have a quadratic function here staring us in the face, but we can figure that out. So let's just go ahead and write a couple of equations just based on what this says. It says, that there are 340 feet of fencing on these three sides. So I know that 2x plus y must be 340 total. All right, and then area. The area of a rectangle is going to be x times y. Now, the area, this is what I want to maximize. I want this to be a function that's a quadratic that I can maximize by finding the vertex. Right now, it doesn't look like that. Usually we have f of x. Well, we're going to call this a of x. The only problem is this has x and y. We don't want a y. We just want x's. But if you go back to this equation we wrote about the perimeter, we can solve that for y. And we would have y equals negative 2x plus 340. And if I do that, I can plug that value in to my area equation or my area function. So I've got x times y, so x times what I just got for y, which is negative 2x plus 340. And then if I multiply this out, my a of x function, my area function, I'll have negative 2x squared plus 340x. Now that looks like a quadratic. It looks like a parabola. It's a function that I can maximize, and that's what I'm here to do, is maximize the area of this parking lot. What value of x, that side, how long does that side need to be in order to maximize the area of the parking lot? Because once you figure out what x is, you can figure out what y is. It's going to have two equal sides, and then whatever's left will be the y. And so we can just find the vertex of this parabola. There's no constant with this parabola. It's okay. That's just 0. So our a, if we write this out, a is going to be negative 2, and our b is 340, and c is 0. So I can use the vertex formula to find x. It's going to be negative b over 2a. And so negative b over 2a is going to be negative 340 over 2 times negative 2, and that is going to be 85. So 85 feet is x. That's the max. That's going to create the maximum value if I let x be 85, and that's how I'm going to get the maximum area for this parking lot. I need to find the y that goes with it because the first question is determine the dimensions, so x and y. So I need to figure out what y goes with it. Now, if I plug this 85 into the function, I plug in a of negative b over 2a, just like I normally would in the vertex formula, that's not going to give me y. It's going to give me the area when x is 85. So I do need to find that out because that is the next question. I'm just going to go ahead and plug the 85 into this y equation here. Just has to do with the fencing, because that'll still give me the right value for y. So I'm going to plug that in. Y equals negative 2 times 85 plus 340. And that is going to be negative 170 plus 340, which is going to be 170. So x is going to be 85 and y will be 170. And so my dimensions are going to be 85 feet by 170 feet. Since x is 85 and y is 170, I can just multiply those together to tell me what the area is. 85 times 170 is going to be 14,450 square feet for the area of this parking lot. If we create it in this way, that will give us the maximum possible area given the amount of fencing we have.